Everybody full of energies here. Look at my friends, all excited. Look at Gediminas, how happy he is on this beautiful Tuesday afternoon. There you go, that's the spirit. Ladies and gentlemen, welcome. Welcome to the epic online technology meeting on lasers for semicon processing. Today is an exciting day, a very, very exciting day, because when we started the epic online technology meetings on the 1st of April, we were talking about femtoseconds. We had no idea how this experiment was going to work. Actually, it's a really, really big surprise that it went so well. And so many days after, so many meetings after, we keep receiving that amazing, amazing feedback from all of you. I have to say that today we got 3 new members. We got Atlant 3D, we got Freedom Photonics, and we got Custom Dots. 3 new members joining the 567 members of EPIC. So we keep growing. I think, Francesca, if we reach 600 by the end of the online technology meetings on the 15th of July, you will sing the Nessun Dorma in perfect Italian on the last online technology meeting on ADAS and autonomous driving. Start practicing. Vincerò. You can do it very, very well. And we start. Actually, we are crazy, completely crazy. On the 24th of June, we're going to do 24 hours of photonics. I'm going to chair a meeting for 24 hours. Don't worry, I have energies and coffee enough for that. I have lots of cups with me. I'm going to be awake for 24 hours sharing online presentations. We start in New Zealand with Southern Photonics. We finish with Facebook Oculus Bernard Kress. So Microsoft Oculus Bernard Kress, we're going to have 24 hours talking about photonics technologies. I also would like to remind that as soon as the situation normalizes, and luckily life has gone its way, luckily everything seems to be okay very soon, we're going to continue with our present meetings as well. And we would like to meet all of you at the meeting that we have in Torino at Convergent Photonics, looking about industrial lasers on the 20th and 21st of May next year. That meeting is going to be epic. It's going to be spectacular. And I also would like to remind all of you that we have a long list of market reports available for you. Carlos went and counted all the view graphs. We have 17,000 view graphs for all of you EPIC members, and we purchased, very expensive, so use it wisely. We purchased the market report from Strategies Unlimited, the worldwide market for lasers. This is already available for you for free on the extranet. If you have any problems to find it, ask Francesca. She will tell you in 1 second how to get it. And also we have now the biggest website to find a job in photonics in the whole world, www.jobsinphotonics.com. We have actively scouted the opening positions from the 567 members of EPIC. I have put it in the website for all the talent in the world looking to find a job in the coolest industry there is. I'm so happy to work in photonics. I want more people to do that. And today we have Infineon facing all the companies in lasers that we're going to ask them what are their challenges in manufacturing. That's the purpose of the meeting today. And we have the very interested in sponsorship. Thank you very much, the sponsors today, Altechna. If you're looking for laser optics or the key partner in laser technologies, Altechna is key on that. If you're looking for optics for the hardened solutions based on IBS, or you're looking for the testing of the optics for any kind of technology or laser-based process, don't go any further than Altechna. Ekspla, the company in the ultra-fast laser segment, both in the lasers for semicon as well as in the medical segment. We are so happy to have Ekspla as a member, and VIGO, all the way from beautiful Warsaw, a company that can develop the best material for mid-infrared detectors, but actually they can do such a fantastic epitaxy that actually a couple of weeks ago, they manufactured even a VCSEL for showing their partners how their technology is so suitable. But most important, today, lasers for semicon, a great menu that our chef, Francesca, from beautiful Italy, is going to tell us what to eat. Francesca, what's in the menu today?
Thank you very much, Jose. So I have to prepare my voice, I guess, for by the end of middle of the. But that's tenor, right? You should find something for soprano, but maybe you have time to do that. So welcome also from my side. So here is our agenda. That, of course, is the boring part of the slides of Jose, right? Because that's the one we like. So thanks a lot for this slide today. That is really straightforward. So we said today we are here, EPIC OTM on laser-based semiconductor. semiconductor processing. So of course, who we want to have here on the menu and that tell us is demands and their demands. Of course, the semiconductor companies. So that's why we have today here Infineon. So even with the talk, so thanks a lot, Benjamin, for being here. But then we have also some speakers, possibly from Huawei, Applied Materials, ASE Group, and onto innovation. So hopefully we can hear a lot of demands from all these companies. And then also from DMP. So semiconductor equipment is also part of the semiconductor, part from Japan. And then, of course, what is the tool? We said laser-based semiconductor processing, so we need the lasers. And we can go directly to the system integrator, so the vertically integrated laser solution, for example, of TOPTICA, that is in the room today, FEIBO as well, and Coherent, so thank you for being here as well. Then we need, of course, laser workstation, so 3D Micromac will also give a talk, so thank you for being here. And then the basic tools, so the lasers. So we have a lot of ultra-fast laser companies, EMEA and also here today, so we have amplitude, light conversion, refined laser system, and Ekspla. So thank you. And then laser diodes. Of course, this is also so monochrome, Amamatsu, and also the oops, sorry. And then it's of course, what we need. Then we need the laser scanning and the optics. So this is served by NextScan technology and PLX. So thank you for being here as well. And then the optics and beam shaping is done by many of our members. So like Skylabs, Altechna, SUS Micro-Optics, Accessories, HoloOr, and our pilot line. So the UFANI pilot line, fabulous for freeform micro-optics. And then who else? Well, of course, detectors we need. So VIGO Systems and Amamatsu are here. And then the laser processes and R&D. So let's not forget, our laser has to improve also for semiconductor processing. So we have our Center for Physical Sciences and Technology, CSEM, and also our laser processing in Lampa, so our EU-funded project. And I guess I said everything. No, we miss the specialty fibers, of course. Glow Photonics. We have even a talk today. So last but not least, the Glow Photonics. Thanks a lot. And so back to Jose.
Grazie mille, Francesca. So first of all, once again, Altechna, Ekspla VIGO, you rock. Thank you for sponsoring today. We are broadcasting this meeting in YouTube, so I would like to tell the YouTubers and also the people in the Zoom channel, if you want to connect with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asoc.com. If you want to connect with any of the participants today or recommend a song for Francesca Moglia to sing on the 15th of July when we reach 600 members, please send me an email, jose.pozo@epic-asoc.com. Thank you so much for this beautiful introduction, Francesca. And now I'm going to be serious, because now I would like to introduce a person who I look up to a lot in this industry. Gediminas Račiukaitis is a key person in bringing industry and academia together, and he has made a huge difference on the way that the laser industry is driven in Lithuania and in Europe. Professor Račiukaitis, thank you very much for being our opening speaker today. The floor and the attention of everyone is yours.
Thank you, Jose.
Acho, Gediminas.
Yeah, thank you. And luckily, I was prepared to meet all of you in Vilnius this April, but we postponed to the next year. But nevertheless, to be impressed what we are doing, we'll start with this. I'm only a RTO presenter in this workshop, so I will go from a little scientific point of view. But for me, it's a pleasure that I saw probably the very few companies we have no contact from the list that are presented here. So it's interesting for that. So simply what we are in Lithuania. We are largest research institute in Lithuania. We are EPIC members since 12, so long term. For EPIC, I'm present at Department of Laser Technologies with different activities, starting from a piece of the glass to laser technologies implemented in the machines. Quite a lot of people, and going to the topic of us today, it's quite difficult to say, but only processing for semiconductors, processing for semiconductor industry, or laser processing for electronics. And description is a little not so simple, so I try to cover a little all of those steps For those not familiar with what is difference, there are metals, semiconductors, and dielectrics. All depends on the band gap, how electrons can freely move in the material. But it makes a difference when we apply laser beam to metals. Electrons are present, free electrons are present, and laser beam is absorbed on the surface. For dielectrics, laser beam penetrates inside the material. Semiconductor is somewhere in the between, semi. For some laser beams, they are like metals, for others like dielectrics. And it makes a lot of difference, and it's difficult to make internal modification in semiconductors, especially some special cases. And there is play between ultra short pulses and long pulses to have some benefit from these interactions. What we are doing, so we're doing processes for semiconductors directly for these materials. It's application in photovoltaics and direct ablation of materials. There is monolithic interconnects in thin film solar cells, different approaches how to connect PN junctions in the thin film materials, doing different approaches, making P1, P2, P3 connections and extracting solar energy. If you got crystalline silicon with some chemical structuring for anti-reflections, we can add some with a laser beam interference, additional structuring for the material to catch more solar light. And if we had all the laser beam interacting with the material, make some defects in it. And if we apply some proper chemistry, we can make inverted pyramid structures that's really good for catching solar light. Another way we are working with direct with semiconductor as a material, we are making with an ultra-short pulse laser terahertz optics made from silicon. It's a direct ablation, making Fresnel lenses, filters, etc., different kind of, especially for development for prototyping. Another areas, it's where semiconductors working on some structures are grown on wafers. And these are examples of LEDs grown as sapphire wafer. We have few patented technologies how to separate this wafer in the dices. So one of the technologies based that we use ultra-short pulse lasers and use two wavelengths, infrared and UV. And with proper selection of this duration, the delay between pulse and pulse energies, we can gain how the energy is absorbed by the material, and really we can get very nice dicing of the material at high speed of this material. New wave in the ultra-short pulse laser, there is burst lasers. So when it's except on having one pulse at some hundreds kilohertz repetition rate, you can get a lot of pulses at megahertz and even gigahertz repetition rate. This also can be applied for dicing of a transparent material like sapphire. In this case, single pulse do nothing, but all the bursts makes that modification across this wafer, and you can separate easy wafer self. Another technology that we are developed in our center, so it's laser-induced selective electroless metal plating. We call it SAIL technology. It consists of laser treatment of dielectric surfaces, polymers, glasses, and ceramics. And after that, few chemical bases to make copper deposition. And on top of copper, you can put nickel, gold, silver, etc., what we like. And our technology is based that we use poor materials, that commercial material without any addition. So it's nearly any thermoplastic polymer can be used. And what we are getting, one of the examples from its processing on the glass, we can get very narrow lines down to tens micrometers, grid of metallic lines that can be used for display, to connect display, and we think that we can make some replacement of ITO from touch screens displays. And really we can get with this quite good spatial resolution on plating in tens of microns and separation between lines. And it's also works on transparent polymers and flexible polymers that are open a lot of options of apply. That's all. Yeah. Oh.
Thank you very much, Gediminas, for your talk.
Questions.
So, of course, you mentioned a bit already at the beginning, you don't have many collaborations for the people that are here. So the slide that was missing was, what can you do for them? What can they do for you? Can you maybe tell explicitly a bit what this audience now that you don't know very well could do for you?
Okay. We have started like Ekspla application lab. So Ekspla is like our father or mother. But we grown up and became independent as all children, yes? We have all the good relation with light conversion, Altechna, all this local community for like supplier. I see Holger, GL Photonics, supply fast components. Kai Labs, it's also some optics. But we see also that companies where we are discussing how to implement our technologies. From other sides, how we are working immediate between providers of components and lasers and systems to the end users, because we can flexible and can adopt our processes to everybody's needs.
Very good. So you gave a good span on the on the audience. And so is there someone who has a question for Gediminas? Because if it's not the case, maybe we can ask Benjamin. You listen a bit to what Gediminas is offering. Is there something, some resolution that you saw? Maybe Gediminas didn't mention all the numbers, but is there something that is appealing maybe for the medium-term future devices?
Yeah, I mean, he did a couple of interesting stuff. I mean, what actually did stay in my mind was the thing that he showed about Sapphire, but that was very interesting, and maybe I will dig deeper into that offline.
Yeah.
You see, Gediminas, if you tickle the users, they are reactive.
Yeah, okay. I'm off it.
Very good, very good. So I guess now we may maybe leave the microphone to you, Benjamin. What do you think? Yes, so you are the next speaker, so why not giving you the floor?
Perfect. So hope everybody can see my screen.
Yes, if you go to presentation mode, perfect. There you go.
All right. Yeah, thank you, ladies and gentlemen, fellow photonic friends. This is the first time that Infineon is joining one of the EPIC online technology meetings, and happily the one laser-based semiconductor processing does fit very well. I want to use the time to briefly introduce Infineon itself as a company, and then I picked up one concrete example because there are many applications where lasers are used in the whole process flow of the semiconductor industry. And Francesca and Jose just give me 6 minutes of time, which is almost like a bullet game of chess. So I will try to speed up and go through the slides with you together. Okay, so who are we? Who is Infineon? Infineon is one of the top 10 semiconductor companies in the world. We have a little bit more than 40,000 employees, mainly based in Europe, Asia, and in the US. We have 37 R&D locations, combined with 17 manufacturing locations. So what are our business segments? What are we targeting on? We're targeting for the high-end applications. So where not everybody can deliver. And here, of course, automotive is very strong. Automotive, the car itself has super many components where semiconductor devices are in. You have, let's say, the electric brake boosters, you have the front light LED, you have airbags, all these kind of stuff. Then we have power sensors and system. So probably your mobile device, your computer, the whole home entertainment, and as well as smart home options are here. You can find here. Then digital security solutions. I mean, we're getting more connected, Internet of Things. We have passports, driving license. All these needs to be secured. Briefly want to show financials. They look good, steady growing. 8 billion revenue last year. The manufacturing sites. So the semiconductor world itself is mainly separated into front-end and back-end processes. So the front-end, they're just thinking on wafer level. That means the whole fabrication process of the wafer, like putting the trench devices, then doing grinding, etching, sputtering, all this kind of stuff is located in the front end. And the back end, as the receiving side, they're thinking about single dies, the die attach, the die bonding, wire bonding, the molding. I mean, the whole carrying around a single die to make it then as a useful tool at the end. And in Europe, we have in Villach and Dresden, the big front-end sites in terms of 300 millimeter. They are the Infineon twins. We do everything like in very close cooperation. Then we have Regensburg as a kind of a hybrid. So they're doing back-end and front-end stuff. And we have two classical back-end locations, one in Warstein and one in Magyarország in Szeged. So what is our position in the market? With the latest acquisition of Cypress, we achieved to be #1 in the automotive sector. That means slightly ahead of NXP, and yeah, it gives us a very good feeling overall. Then we have the power discretes and modules, and here you can see Infineon with 20% is almost double as much as #2. Like on semi, you have ST, Mitsubishi, all the other big players. And security IC is also one of our big markets, and here we heads up with NXP. So where do I sit? I sit in Villach. It's in the south of Austria. I'm not sure if you heard about it. I haven't before I joined Infineon, but it's really beautiful in the south of Austria. So a lot of nice mountains, lakes. Italy is very close, just 15 minutes. A very nice place to live. And here you can see, for example, our new 300 millimeter factory. We have a new R&D building. Myself, I'm sitting somewhere here at the moment as we speaking. And this is the classical front-end manufacturing side where you have a lot of R&D buildings, and here the fabrication. So let's talk about a concrete example, wafer separation. This is pretty challenging because you get a very thin and fragile device, and this also needs to special needs for the handling itself. I mean, you cannot just pass over one very thin wafer and expect that it will not break. That's why you need to put it on tape and frame. And also this is some stuff that we need to consider when it's not just the laser process itself. Of course, this has to be very reliable. And if you imagine you have here 12-inch product, so 300 millimeter wafer, and typical die size of 1 by 2 millimeter, then also the alignment is challenging. So the whole handling and alignment is very crucial for us and very essential for our fabrication process. So, but mainly we run with 12 and 8-inch in high volume production, and some special R&D projects are also coming with lower wafer sizes. But overall, there are different materials. I mean, clear, we have silicon carbide, gallium nitride, and there are a couple of other interesting upcoming new trends. The die itself, I mean, you can see they become like super thin, and why are they getting so thin? I mean, as thinner the bulk material gets, as better is the performance in some ways. That means the air on, the resistance is lower, and also the heat dissipation is better for the whole system. And if you think about advanced packaging solutions, then of course you need a thin die, or if you have something flexible, then you cannot put a big die inside. And here I wanted to give you some pictures. Actually, I put it out of a publication that one of our big back-end guys, Michael Raj, did. His aim was actually not really to show the benefits of the laser. He wanted to understand how the copper backside is influencing the die strengths. Die strength is a very important criteria for us. I mean, how strong is the chip? How strong can it resist on a force applied in the backend? And he checked for different copper back sizes how this will affect, and if the classical linear 3-point bending approach is still valid for ultra thin devices with the large copper backside. And here you can see a classical stack. I mean, we have different materials inside. Here you see that the trench devices that are creating the final MOSFET device. And here, of course, the laser is a very flexible tool. I mean, you can easily fine-tune your laser parameters to the needs of your material. And actually in the semiconductor world, we're doing like very successfully since many years beam shaping and beam splitting in 24/7 reliable production conditions. But of course here we want to understand, and that's why we're actually here, because we as Infineon, we always want to connect to gain synergies, and Infineon spends roughly 1 billion euros a year for R&D. And I mean, you guys are at the front line of the photonics development, and it's super interesting for us to get the informations out of first hand from you guys. I mean, maybe it even opens new things that can be achieved that we was not thinking about before, because yeah, nobody was doing it. But you have a good idea, and then we try to realize that in an early R&D project that can finally be then released into a productive tool. And yeah, that's why I'm here, and I'm very thankful that Francesca and Jose is doing that so nicely.
Thank you very much, Benjamin. You cannot imagine how happy Francesca and me are together right now, because you told us, it was like a month ago, you said to me in LinkedIn in a message, are you interested in having an end user like Infineon in an event on lasers for semicon? And look at this, we made it happen. I'm extremely happy. We are here to make sure that all your challenges are covered. And I also would like to also remind that we also have a couple of other semiconductor companies in the room. I'm going to also say hello to a couple of them. We also have from Huawei, we have my very good friend Ricardo. Ricardo, how are you doing today?
Hello, hello and good afternoon. Just a second. Okay.
Yes.
Hello and good afternoon. I'm Ricardo from Huawei. As most of you, I don't need to introduce very much Huawei. I think Mr. Trump made that work already. So let me just introduce our institute. We are Huawei. I belong to WMTC. It's called the Weilheim Manufacturing Technology Center. We are looking into many manufacturing technologies from R&D level for all kinds of different applications, from RF, let's say 5G, to silicon photonics, to power, to all kinds of businesses that we already have to support existing business and to look into further technologies, say how can we do it in a better way. So this is our business here in Germany. Weilheim is located just about 50 kilometers south of Munich. So most of you, I would assume that you may be aware of our big research center in Munich. We are very close to them. And yes, and we are here to cooperate with many different companies on let's say, a point-to-point project.
Thank you very much, Ricardo. We're going to have lots of questions to you. I'm going to also introduce another semiconductor company, because this is the magic of LinkedIn. So Brian Ball commented on one of my posts about, oh, that's an interesting set of online meetings you're doing. I said, wow, Onto Innovation, you have to come to one of us. Thank you very much, Brian, for being with us this beautiful afternoon. What is Onto Innovation, and what are you looking for in a meeting like this one? You need to unmute yourself so we can hear you.
Yes, how's that?
Yes. Yeah, perfect.
Thanks, Jose. Thanks very much for the invitation. I'm happy to be here at 6 o'clock in the morning at Pacific time. Yeah, I have a lot of interest in this industry all the way around. I have been in silicon photonics and wafer processing, memory repair, and now currently at Onto Innovation. This company maybe does need a little introduction. It is fairly new from the merger of Nanometrics and Rudolph Corporation. So we are finding our path now as one company with a lot of synergies. We're doing mostly process control equipment, but using lasers. I see some of our vendors here, Amplitude, VIGO Systems, and some others, and some customers as well. So my interest is in just looking at the current state for some of this laser processing equipment available and some of the applications.
Thank you very much. The floor is open for questions now and during the whole next 2 hours for the 3 key companies that we have on the user side today. And the first one for Benjamin is coming from the YouTube universe, James Field, who is the CEO of the company Vadient Optics. In the 3D printing of micro optics, these guys are really, really promising. James is wondering, does Infineon see growth in volume silicon carbide wafers that you use for power devices?
Silicon carbide power devices, sure.
Yeah.
It's the big next market.
If you could talk about the
interest.
main challenge on silicon carbide processing in the laser industry, what would that be? Are we looking at ultra fast? Are we looking, is the problem with the power being stability?
No, I mean, first of all, I mean, for the separation process itself, the photonic industry is mainly competing with a classical mechanical saw. That is really, I mean, they're doing this for 30 years and they're doing an excellent job. But as soon as we come to really thin devices and as I mentioned, different stack sizes, then they also come to the limitations because maybe the wheel is not resharpening anymore or they are like chipping that's violating some specification. Yeah, but for silicon carbide, I see a very good chance, and I mean there are already very good results on the market visible to use a laser. So
I want to go through every single component in the semicon industry. We're going to talk later about through silicon bias. I also want to talk about through glass bias. I want to talk about micro optics integration to semicon, but we have 2 hours for that. And I want to make sure that everybody intervenes. So I'm going to go to the next speaker today, which is one of the key members that we have in EPIC because he just arrived to EPIC and there is so many companies asking to be introduced to them. Semi 3D Micro Mac. We have Hans-Ulrich Zuehlke with us today. Thank you very much, Hans-Ulrich, to join us and tell us about 3D Micro Mac and most important, what can the laser suppliers and the end users on the semicon do to make 3D Micro Mac even better than it already is. The floor and the attention of everyone is yours.
Hello, everybody. I'm not sure if I'm online now.
You are online. We can hear you loud and clear.
Perfect. Okay. I have some trouble to share my slides, but I will try. So I can't use my original device.
Just let me know, otherwise I can do it. I have your slides here.
Yeah, then please do so.
I do it? Okay, fair enough.
Okay, that would be perfect. Okay.
So.
Yeah, thank you for this. Okay.
Thank you.
Yes, I like to talk about laser systems for the semiconductor industry. Next slide, please. Next slide, please.
Oh.
Okay, so yeah, we are 3D Micromac. We are a company developing, producing, selling, servicing tools for microprocessing. You see a few facts about our company. We are funded in 2002 with over 170 employees now. We are based in Chemnitz, Saxony, Germany. We have our headquarters there. We produce our tools in Germany. I like to highlight that we have the application center and the contract manufacturing opportunities also in Chemnitz. And we have nearly 600 installations now worldwide with our microprocessing tools. For today, I picked out a few tools for the semiconductor industry. So we have much more tools, but these are tools with relation to semi industry. We have tools for annealing, for ohmic contact formation, to sinter the very first metal layer on the backside of silicon carbide wafers. We have tools for dopant activation. We have tools for preparing materials for microscopy, for instance, for doing TEM lamellas. We have dicing tools. We have lift-off tools. And in the upper right corner, we have our tool MicroVega XMR. And I like to introduce a little bit more this special tool today. Okay, next slide, please. Next slide, please. Okay, thank you. So what's the idea behind this tool? If you have a sensor based on the giant or tunneling magnetoresistive effect, if you take the sensor, you have a magnet on top on it and you move it, you will get different electrical signal. The resistivity will change depending on the magnetic field. If you put together a couple of the sensors in a Wheatstone bridge, then you will get an integrated magnetic sensor. If you add the logic, then you will have an integrated measurement device. And you can use this for positioning sensors for e-compass. You see a few samples of application. The detection of position of steering wheels, of the DC motor, of e-compass applications, e-compass in the virtual reality, Google, many other applications. And I like to show today the tool, what we are using. Next slide, please. So we had several requirements and challenges before we designed this tool. We have many different sizes of the sensor. So we have to use a motorized aperture to adapt this laser spot. The basic idea is on the lower right corner, you have the different sensor areas. You apply a magnetic field, and one sensor you heat up by laser with one laser pulse. And then you fix the position, the orientation of the magnetic field. You remove the laser and the magnet, and the orientation will be stable. And then you rotate the magnet unit, and you get all the required magnets in the Wheatstone bridge. Now we have different sensor sizes. We have different positions on the wafer, so we need a very nice synchronization of the laser and the motion system. We have to adapt the magnetic field strength for the different products and stack systems. We have different numbers of magnetic orientations. We need very homogeneous processing to get very sensitive magnet sensors. And at the end, if you like to do smaller devices, you have minimum spacing, and we need very precise positioning. To give you an example, we can do more than 500,000 sensors per hour. That could mean for a typical device, what we are just doing, 2 wafers per hour. The tool is already approved for production, and we are doing much more evaluations at the moment. Next slide, please. Yeah, what's the outlook? So the tool is running stable, very successful. We are looking for other applications than the magnetic sensor. So at the end, any application would be interesting where we have to do selective heating of something on a silicon wafer and not necessarily a silicon wafer. We like to improve the in situ process control. We have a lot of process control, but not really an in situ process control at the moment. And of course, we like to increase the throughput. And here, it would be nice to have better possibilities to synchronize laser pulses with the motion system, to have more stable first pulses. And maybe finally, the higher pulse energy will give us the opportunity to process larger areas. Conclusion, we have a nice tool running in production, doing selective sensor processing with very high throughput, saving a lot of costs compared to the old production strategies. But we are looking for some improvements for the future. That's it. Thank you.
Thank you very much, Hans-Ulrich, for your talk. So let me unshare now. Yes, there we are. So, so thanks a lot for your contribution. So I see, Benjamin, you have a question. Is it correct?
Yeah,
there you go.
I was wondering, I hope I was not mixing up things, but you guys also developed the TLS, right? The thermal laser separation.
Yes, that's cool.
And what happened with that? I didn't see here anything. I mean, is this
I mentioned the dicing tool. Yep. I mentioned the dicing tool. It's not enough time to speak about all these technologies. Please feel free to contact me for more details about the TLS dicing. So we do still the TLS dicing. It's the cleaving technology based on a thermal shock.
But is it like the control of the crack? I mean, you do initial seed crack, and then you guide that crack via laser, and I think some cold air or something like that. Yep. And this is this very reliable? I mean, I always was afraid that maybe the crack runs away or stays behind, or is this like really for 27 per operation ready?
It is ready. It's running in many photovoltaic applications. So we cut solar cells. We did a lot of tests for silicon carbide because this is an extreme hard material, and here it makes absolutely sense to use the TLS technology. Yeah, maybe we can discuss more details in a B2B discussion. It runs under reliable production conditions, and of course you have to consider some, we call it golden rules. So chip size, metal thickness on the backside, but we can handle the most of this requirement.
Okay.
So it works.
Thank you.
Very good. So, is I remember well, there is Nathan also from Lahore that want to have a question. Yeah, you're muted still.
Hi,
Yes.
do you hear me?
There you go.
Hi. So, thank you for that presentation, Hans-Ulrich. As you know, we have a good cooperation with 3D Micromac, and I wanted to ask you something about the magnetic sensor system. You mentioned two needs. One about the fact that you use a motorized aperture to control the sensor size, and the second one about homogenization, which you solve by some sort of beam shaping. Regarding the motorized aperture, do you do this by clipping? I mean, is this something?
Somehow it's clipping, cutting off of the outer regions of Gaussian beam profile. Yeah.
Yeah. So
at the moment, yep.
So would you not rather have a top head profile and change the aperture size without clipping?
The practical answer is it was good enough up to now.
That's a good
but yes, of course, you are right. It might be worth for future applications to have a look on top head profile. Yeah.
Okay. Thank you. Just well, you know us. If you
yes.
Thank you.
Very good. So are there other questions? Because we heard a couple of challenges like synchronization, a stable first pulse of the laser. Is there some laser manufacturer that wants to comment? Or maybe I just ask to introduce yourself also if you are available for this. Or for example, we have Dirk from Coherent. Dirk, are you there?
Yes, I am. I actually do have a question.
Okay, great. Then
I do have a question for 3D Micromac. So do you find that there is anything on the laser side that would improve your throughput or the performance of your system?
Yeah, we have some issues with synchronization. So at the moment, we are running our tool in a mode that we have a nice synchronization with we choose the speed of the motion system what fits to the repetition rate of the laser. The best way, of course, for throughput would be if we could selectively pick out some pulses by pulse picking or by having a laser which would allow us to initiate pulses, trigger pulses on demand. But then we need really a stable first pulse here.
I see. So the first pulse suppression or first pulse control is one of the important things.
I didn't mention this. We use usually one pulse per sensor.
I see. Thank you.
Great. Then now that we are running, and I see that Quentin is writing something, right? Quentin, maybe you can introduce yourself and tell us why Amplitude is here today. Thank you.
Yeah, good afternoon. So I'm Quentin from Amplitude. So we are ultra-fast, mostly femtosecond laser maker. And so laser only, but it's interesting to hear something about pulse on demand and energy control, because it's indeed what we are targeting and where we can help indeed. So happy to hear that.
Very good, very good. So if there are no other questions, because I think I don't see anyone else. No, Martynas, please.
Hello, this is Martynas from Light Conversion. So I just wanted to ask, when you're, let's say, when you're saying synchronization, yeah. So it's never an how to say, an absolute synchronization, or only when you're speaking about the lasers that are, synchronized to synchrotrons, they are really with the precision of the femtosecond. So can you say a frequency or a time duration where it's good enough to synchronize the laser to? Because there's one thing to doing a synchronization up to a precision of a few hundred femtoseconds or tens of femtoseconds, and this is doable, but of course it's a bit more complicated. There's another thing to do with the precision of an oscillator. There's another thing to do, with the precision of amplifier frequency, and all of those things are doable, but it just puts a different, how to say, complication. Yeah.
Hans-Ulrich?
Do
you hear us? Because this would be interesting, yes? If they need a femtosecond synchronization, it might be a challenge. But maybe in the case you come back later, we wait for this question. And Martynas, let's keep it in mind. Let's not forget. Are you back?
Yeah, I'm back.
Yeah,
I don't know.
Yeah. Did you hear the question of Martynas?
Yeah, sure. Yeah.
Okay, very good.
Only my microphone is the challenge. Okay. Yeah, so we have in mind the precision of 5 micrometers. So, and we work with 10,000 of hertz, and this is somehow the range where we are working and what we need. So it's not nuclear physics what we are doing, but we like to run our tool with more than 100 millimeter per second, let's say. This is what we are doing at the moment, roundabout. And it would be great to have a solution for irregular pattern also, for different distances between the sensors. Okay.
Okay. Yes. Is it something similar for you, Benjamin, or is it maybe more strict or less strict?
For us, I think it's a little bit different. So that question did not really fit to my needs.
Sorry.
Fair enough. Fair enough. Okay, then I guess now we might be all set for the next speaker. So it's time now for Altechna. So Eduardas, please, we can give you the floor now.
Hello, everyone. Just a second. We'll try to set the screen and begin. All right, can you see it?
Yes, perfect.
Perfect. So very, very brief introduction without any slides about our company. We are the provider and manufacturer of optical components and optical assemblies. Mainly, we are working and we are doing partnership with laser manufacturers and laser system integrators. It would be very, very interesting somehow to reach, of course, the end customer, but usually the end customer requires this middleman. For us, it is our customer, laser system integrator. My colleagues have chosen me to do this presentation because most of the time I am based in China, Shenzhen. I am the general manager of our established company for customer support and sales. And in general, China, maybe not only China, but East Asia is a powerhouse of the manufacturing semiconductors. So I would like to share trends with you, what we are seeing in Asia. These might be not the absolute trends. This is what we are working in Altechna. And let's begin. So I have decided to talk about 3 main topics separated on the lasers, wavelength of lasers to be precise, what applications our customers now require us to do for them, and what the solutions we are providing now in mass production for them. All right. Let's start from the 1 micron application. So here I'm not sure who is driving the market. Is it the application or is it the laser manufacturers? Because from our side, we can see that sometimes there is a drive in the academic area, or maybe also in the market, but if there is no laser for this application, so in that case, the process is stuck. However, recent years, more and more laser manufacturers have provided to the market high average power. And here, this is a very important part, high repetition rate lasers. Usually it goes femtosecond, sub-picosecond, not always. It also can still go nanosecond regimes and so on. So for these kind of high repetition rate applications, the problem that we are having is very, very similar as with CW lasers. We are calling these quasi-CW effects. And it is not only the possible damage or shorter lifetime of the optics because of the high energy of the laser, but it is also about the heat on the edge surface of the optical element or inside of the element. So for this kind of problem, we need to build optics with the minimum possible absorption. So now I would say that the market, we started from the market is that the optics should be for these kind of lasers and applications less than with 1 ppm absorption. Here, just sharing some of the actual results, measurements which were provided by our partners of the absorption measurements and of the laser damage threshold measurements. Particularly, these approaches were used not only for the cutting, scribing, semiconductors on the wafers and so on, but now we are successfully implementing these in this market and in this applications too. Next big development that probably most of us noticed is the PV processing, mainly used green wavelength, 515 nanometers, 532 nanometers. But here again, with high average power lasers and with high repetition rate, new applications are emerging to the market. One of these are PCB selective drilling or selective layer removal, like removing copper, fixed thickness and so on, but not damaging other layers of the process. So for this, we have collaborated with one of our biggest customers to develop then the alternative system, moving z-axis, actively moving z-axis of the focal spot, and also changing the laser beam diameter at the focal spot. To do that, we had to achieve the as best as possible precision and the repeatability. The main demand was that the beam divergence would be less than 0.1 milliradian of the half angle. So the graph, the graph in the top right, and the above is the repeatability test under the temperature shocks. As you know, most probably in any factory, you can get these temperature shocks when something goes wrong, and here we are still under the requirements of the customer. The final big thing last year that we have noticed, again, came from these first harmonic high average power lasers. Now everybody is talking, we want to work with 20 watt UV, we want to work with 30 watt UV. But here, I would say not the optics inside the lasers, but the optics in beam delivery is the main obstacle because, well, it's burning rather fast. Here, in collaboration with our partners, I would say sister company, Workshop of Photonics, and with many, many academic researchers here in Vilnius, in Southampton, and so on, we are developing beam shapers, different beam shapers that market are used to. These are structures inside, nano-grating structures written inside of the glass, so they have the same lifetime and laser damage threshold properties as the glass itself, particularly if used silicon. So we can make the beam shapers for the UV applications, which have rather high total transmission, here in this graph, you can see that still in 355, the transmission of uncoated optical element would be more than 85%. But the most important part that it will work as long as the glass itself. And if you noticed in my slides on the left side, there was always the part of the partners or the collaborators that helped us to develop one or the other application. So I just want to repeat my colleague, Laurinas, who was speaking a week ago, I believe, that the collaboration is the key. And I hope so that we will have more and more opportunities to collaborate, developing together the right solution for these high demand applications in semiconductor field. So thank you.
Eduardas, do you know what is the best way of starting a collaboration? To answer the epic question, what can you do for them? What can they do for you?
Yeah, so from our side, regarding, for example, these 3 projects, we are willing to invest our time, our efforts, even our money, if customers, end customers would be willing to test our developed products in these applications. And if they would be able to give us a feedback where we can, do better, that we would be able to achieve the required results, I have no doubts that in this case, we would bring the value to both parties. Eventually, of course, we want to make money if it goes to the mass production, but from our side, we understand we need to solve problems for the customers. So this is how we can help each other. Please ask us. We will provide you the products for testing and the products that actually are in our mind on the edge of the developing market, that in a year or in a 2, we together will be able to use in mass production.
From the couple of decades I've been in this industry, what I have noticed is the best way to make money is not to solve the problems of your customer, but to know the needs of your customers' customers. And this is what we have today here. We really have the semicon industry and the ultra-fast laser manufacturers. I'm going to go to the latter because Refine Laser is a company that I really look up to. I was very happy the day that we got the form from them, and we actually have them represented in the room. Thank you, Max, for being with us today. Can you tell us what Refine Laser is and what are you doing today at this beautiful meeting?
Yes, thank you very much for the introduction. So we are a young company offering fiber laser systems that are very widely tunable in wavelength and very rapidly tunable in wavelengths. So we have developed a new laser technology, fiber-based laser technology, that allows the generation of laser pulses in the range of 400 nanometers to more than 2000 nanometers with a power of several 100 milliwatts. So we are not suited for micro processing or marking, but I think our laser systems are very well suited for monitoring applications. I think in the process or in the processing of semiconductors, there's a high demand for active monitoring solutions, for example, for the critical overlays or the critical dimensions. And I think with our broad wavelength coverage combined with high power, we can offer a very practical alternative. So, like I said, we are a young company. And we are looking for, well, anything actually, all kinds of partners and pilot customers. So if you're interested in this technology, please contact me.
Oh, we are very, very interested, but the reason we actually gave you the microphone is because I more or less expected what you were going to say. And during the presentation, I was talking to Francesca on the line saying, we need to know a little bit about Infineon's demand for resolution and accuracy. So, Benjamin, when it comes to the critical dimensions in the semicon process, are we talking about the 12 nanometer node or are we talking about something different?
Yeah, I mean, it depends a little bit on which process step you're looking into. But I mean, in general, as you know, many of these etching steps, they are super precise and super much defined. So I think here it will be also challenging for the laser to compete with the classical etching. But I mean, we have lift off, we have marking, we have dicing. There are many different applications. And here, I mean, you have to hold 300 millimeter line in a 60 micron dicing width, like very precise. I mean, of course, you don't want to have a cut like and then a large angle. So actually, a few microns resolution is needed, yes, and very precise in 24/7 operations. So the alignment itself is very crucial for us. It's
the yield of Infineon process is in the close to 100%. Is the beam shape a challenge? Keeping the beam shape constant over the whole process a challenge?
I mean, the guys who are fabricating do a pretty good job. So, but you're right, beam shaping itself, I mean, you always have to monitor precise your whole optical path, and you cannot allow that one tool has a high deviation from the other tool, because at the end of the day, the quality that we are delivering should be the same thing independently over which tool it comes. And especially here, yeah, we have a very strict and harsh requirements for precision and also for matching, tool matching itself. I mean, of course, it doesn't make sense if you can just deliver one tool and you can not create a second tool that gives the same outcome. So this is very important, yeah.
You see, Eduardas, how it works. So you go to your customer, which is refined laser, and you ask him what can he do to go to his customer, and quickly you go to beam shape, which is the expertise of Altechna. And I think there is obvious room for collaboration. Eduardas, when it comes to high fluence, high stability, what I have been seeing lately, quite a lot lately, is the need for IBS coating. Is Altechna looking at this technology? How do you feel about the IBS coatings for semicon processing?
So let's say our bread and butter is IBS coating and point-of-return sputtering coatings, sputtering technologies, but we are using these technologies for making the optical components that further are used in the lasers and laser systems. So in general, I know that sputtering technologies, for example, Professor Gediminas Račiukaitis have talked a little bit that they are used to structure some PEN structures and so on to achieve the required parameters and so on under the highest possible precision. For us, again, we are using the same sputtering technologies or maybe a little bit different approaches, but sputtering technologies to achieve the highest precision of the coatings that we would be able to deliver afterwards, the, let's say, lowest losses from our optical elements, the lowest possible absorption, and so on. And that's how we are bringing the stability to the process itself.
Excellent. For me, one of the key questions that I want to answer today from the semicon companies is really a little bit of the challenges, what I call the Santa Claus Christmas list on either the beam shape or the ideal laser. On that, I'm going to ask our new friend from Auto Innovation, Brian. How do you feel about this? Could you give us the Santa Claus Christmas list of the ideal laser process, either on beam shape or on the laser specs for these people?
I think, you know, as far as beam shape goes on some of our applications, as we change power level or on one tunable laser wavelength, the changes in the beam parameters can give us really a problem. So the more stability you can get over the full power range and over a tunable wavelength range, the better for our process.
What is the wavelength range tunability that you are expecting, more or less?
Oh, yeah, I actually, we're just not announcing the product yet, so I can't give the full range, but it's over several microns in the IR. But this was just one example. This is an issue with changes in power as well, that the beam parameters change somewhat as you're changing the beam power from the laser, and it causes the spot down at the wafer to change, which we need, obviously very good control on when we're talking about sub-micron positioning and accuracies. Yeah.
Francesca, we're getting somewhere here. We're getting about femtosecond synchronization. We're getting about wavelength tunability. We're getting about very stable beam shape. But the nice thing here that Brian said is about a few microns wavelength tunability, and I expected that. So I'm gonna go to Poland. I'm gonna go to VIGO Systems because they are making a big difference. They are making a big difference in the field of mid-infrared sensing on many different applications. I think you guys are gonna be amazed on the revolution that the VIGO system from Warsaw is developing on this industry. Thank you very much, Dziękuję bardzo, for being with us. The floor and the attention of everyone is yours.
Okay, just a moment. Okay, welcome everybody. My name is Jerzy Łach from VIGO Systems Poland. Thank you, Jose, for introduction. It is my pleasure to be here to try to help all of companies and people to develop the systems based on lasers. So briefly speaking, just information about the company. We are quite old, let's say, company with 30 years of tradition in semiconductor processing production from the scratch to the final product. I don't want to stay here that too much because we have only 6 minutes to go. So just briefly speaking, we have complete production line from epitaxy processing and dedicated applications like electronics and packaging and other additional equipment which is necessary to use the detectors and microlenses, the packaging and other custom possibilities to do with our detectors, and we are doing a lot of custom projects for our customers. So I was wondering what will be the major application of detectors, because we are indirect in that applications like laser semiconductor and PCB processing. So what do we see in that market? We see two major applications in terms of use our detectors. This is the laser, in general, laser beam shaping in semiconductor processing, and kind of testing of PCB processing during the production process. So, of course, if we go into the details like wafer processing using lasers, we are present in laser beam parameters measurement, which is used in dicing, milling, etching, producing the UV light in lithography, and laser pulse measurement, and beam positioning, and via hole testing during PCB manufacturing. So some of you mentioned about those applications today, so I'm glad to, my point is to show you some solutions for that. So I was wondering what is the best what we can do for you, because this is the topic of that meeting. So we can offer to our customers some detectors with fundamental limits, which are rich with different materials, and we are well known in the market with very fast detectors which are suitable for fast laser pulses measurement So one of you today mentioned about the laser pulses measurement. So I think we could have some common points to develop our cooperation. So we are able to offer the detectors which are suitable for laser beam shaping during the producing CO2 laser beam, where the detectors are used in the optical amplifiers of laser beam, and on each step of amplification have to be measured what is the parameters of the beam shape. So this is, we think, the point where the detectors can be used. Of course, quadrant geometry detectors can be used to adjust the laser beam during the processing to hit the right point of the processing. Yeah. So of course these are also only exemplary detectors used for that application. The next one is a detector which can be used for let's say higher laser beam powers during the laser beam processing, like etching, like dicing and laser milling, when the laser beam have to be controlled very precisely. So we can be a part of that system. So of course, if you speak about the laser beam positioning, we can also offer to our customers the linear arrays made with some different materials with different wavelengths and different speeds. So we are always open to cooperation. If you don't see any specific type of detector which is suitable for you, of course we are open for making custom projects or make common projects to develop the laser systems. So that's all from my side, briefly speaking about what we can offer for you. Of course, feel free to ask questions and thoughts about the presentation.
Thank you very much, Jerzy, for your contribution. Now we are back to the room. So let's see, is there someone, because I have the feeling we heard beam shaping so many times and Gwen didn't take the microphone yet. So Gwen from KaiLab, so thank you for being here today. Do you want to comment maybe also about previous requirements like stability and what KaiLabs can do for all these people?
Hi, Francesca, can you hear me well?
Yes, very well.
Okay. Thank you for again one more very nice online meeting. This time on Semiconductor. It's very interesting. It's especially very interesting to have the end user among us telling us about their need. Honestly, I've paid attention to the VIGO presentation, and I've noticed that you are doing very nice detectors. I don't have specific question on that, but I take note on what you are doing, and maybe we could together collaborate on some project or something like that. A few words about KaiLabs. Yes, indeed, we are doing beam shaping, and we are very much interested in the semiconductor industry because we do a lot of projects of beam shaping with USP lasers, so femtosecond lasers. We have worked with Amplitude, for example, who is here, even if I don't know Quentin personally, but we have many other contacts in their company in Bordeaux. What we are doing actually is a lot of beam shaping in terms of shape. It can be tapered, but it can be more complex shape, which are stabilized. So that's a very important point when you talk about USP processes. So indeed, when people were talking about stabilization, I took note, and yes, this is a change that we have actually managed to take, and we made a big improvement on that. And that's also a topic that has been discussed with Amplitude, for example, and which is still actually being discussed. On the side, just want to say that, yes, please contact me. We are handling very high power in terms of average power or peak power. And what we are doing is compatible with the machines that were shown today, compatible with scanners and compatible with FTMC. So I hope that I will, again, as usual, get very nice contact through this online meeting. And thank you, Francesca, for the introduction.
You're very welcome, Gwen. So now we get a bit. So we heard a bit about this repeatability, stability of the pulse shape on the wafers. But what about bringing the beam there with a fast scanner? So we have here today Lars Penning from NextScan Technology. So maybe Lars, you want to introduce yourself and say what can you do for this technology, for this industry? If you unmute,
let's
yes,
unmute. Hi there,
you are.
everybody. Good afternoon, good morning, good evening. A lot of interesting topics, of course, mentioned by Ben, and also the beam shaping. Yeah, it's always a challenging topic, as already addressed by some of our attendees. Right, so. Yeah, fast scanning is possible, of course, with the ultra fast pulse lasers, and I've heard a few things on pulse repetition rates and all those kind of points of interest, especially when it comes to managing the thermal load on the semiconductors. We also always talk about ultra fast pulse lasers, but if you put all those pulses next to each other, you might accumulate some energy and then you lose the benefit of ultra fast pulse lasers. So scanning strategies is definitely one point of interest which can help, and also again beam shaping. But yeah, it also everything introduces challenges. So let's see how far we can get. But at the end of the day, it's the end user who sets the requirements. So again, it's very useful to have companies like Infineon on board to mention what they are looking for. So looking forward to that.
Lars. So for those of you, these polygon scanners that we are using to actually scan the beam over large surfaces, do you have any challenges when it comes to reaching the edge of the polygon? Is there a challenge there in the repeatability of the laser beam or the stability of the laser beam?
Well, it's that I think it was our friends from Lithuania who mentioned already the seed clock. There is you need to have a master clock in a scanning system. And the master clock will set the final timing on the system. So there got 25, 40, 50 megahertz, 80 megahertz. Those are systems which determine the synchronization of the system or the positioning accuracy in the system. So that is where you need to look for solutions. And that is something where polygon scanning can offer a solution, for instance. Yeah.
I spotted a collaboration from Kylabs here. Gwen. EMEA, yes.
Yes, I'm on mute. Okay, great. Yeah, actually, I have a question for NextScan. Somehow we are very oftenly, I would say, limited, if I don't like the word, but limited by the scanner aperture. And I know your scanners are actually quite well, at least the standard one. But I was wondering, do you have in your roadmap to develop I would say large aperture scanners, or what is the larger aperture that we could imagine with one of your scanners?
Yeah, so interesting question, because a larger aperture also means a larger polygon, and that is where the costs fly in, because if you scale up the polygon motor assembly needs to scale up, and with all these scaling up, the scanner system itself becomes more expensive. So it depends on the application whether it's justified to go into a larger aperture system. So that's, I think, at the end the key question: does the application justify the additional cost of the scanner and laser system?
So I guess Nathan has a question. So we keep. Okay.
A small question about polygon scanning. Do you have issues with the tolerances on the facets? I mean, if you had a solution that would be transmissive and you're still rotating something and would scan fast and had no tolerances on angles, would this be interesting to you?
I also wait that there are different ways in order to compensate for manufacturing tolerances, especially with the polygon. There are always tolerances because it's a mechanically manufactured product. So if you are able to map the geometric errors in your system, then you can compensate them with an active correction. Because the errors are always the same, or most of them are the same.
There were no errors on the polygon. If it was a diffracted polygon.
Yeah, so that is what is already in place, or at least when we look at our scanner systems, we have an active correction. And of course, there are solutions from the graphic arts where you can do a passive correction, but power-wise, they can be managed. So it's always a trade-off. Again, it's a trade-off in solutions, and you have to balance. Okay, how do you solve an issue? Do you solve it optically, electronically, mechanically? And that is where we always try to balance the solution. But again, it's not always easy to come up with the highest precision. So again, does the application justify additional efforts in order to get to a specific specification? Yeah.
I have a question for Lars, a follow-up question. So you mentioned that going to a larger aperture means you have to get larger mirrors. What is the major cost driver of polygon scanners? Is it actually the mirror assembly, or is it the control electronics, or is it the optical system for beam shaping?
It's the if you break down in our case a polygon scanner system, the polygon motor assembly and the full telecentric optics we have are the two cost drivers in the system. Then again, there are always ways to reduce cost, and one of them is of course have a large volume, so that always helps. The other topic is, of course, what does the application need? Does the application need a full telecentricity? In case of semiconductor, you would like that, of course, because you want to have a constant spot size over the complete scanned area. So that results in specific curved mirrors, which are relatively expensive to manufacture, especially when they get larger, and that's where the costs are most of the time. Yeah, but electronics, electronics is not really it's a one-time engineering effort, and then it's about multiplying. So it's more the optics. The optics is the most expensive, or is the cost drive in the system. Yeah.
Very good, very good. It's funny because is this exactly the moment where Lars asked 3 times, depends on the application, and then all the manufacturers wants to know, what can you do, what can you do? And so now it would be nice maybe to hear if Benjamin or Ricardo or Brian is actually a challenge for Lars, so that the all manufacturing groups can follow then using the polygon scanners of Lars. Is there someone who wants to comment? Don't be shy.
Sure. I mean, the idea of the polygon scanner in combination with the ultra short pulses, I think it's great. I mean, if you follow the trend, high average power, high repetition rate, as Lars mentioned, you need to move fast to really gain the quality or the quality improvement that you expect from femtosecond applications. Because I've seen a lot of applications where some guys in an application lab on a very small size achieved some good results. But of course, this is nothing that you can then directly use for 300 millimeter 24/7 wafer separation. I mean, you have to also consider the chuck where the wafer is laying on. I mean, you follow the same path a couple of times, so there is no room to, let's say, do additional annealing of the side wall by applying 100 additional overscans. I mean, I've seen such things, and so I think the polygon scanner is really promising tool, and I'm happy to have Lars here as a presenter. But I was also wondering, I think one short question for Gwen from Kali Labs, because I think one some epic shows ago, she mentioned that she can do some, or she can compensate or block peak-to-peak variations during splitting or shaping of the beam. Do I have the correct in mind? Didn't you mention something like that? That you can compensate?
I don't know exactly what you are referring to.
I show it on YouTube to you.
Yeah, no worry. So do we mention too? What we do basically, there are two things where we have nice results. One is beam stabilization, but I'm not so sure that's what you're talking about. Beam stabilization is key if you want to do beam shaping with ultra-fast lasers, because if your beams is not that stable and it's very difficult to have a very stable beam, then your shape beam, I mean, the shape is changing a lot and you have to realign all the time. And we have developed some specific feature to stabilize the beam before the shaping itself. And this is really fully based on our core technology MPLC. So I did talk about that. And yes, we have very nice results on that actually, but I can talk 1 hour about that. So we would have to call each other to discuss that again.
All right, yeah, sure. Yeah, then I will drop a mail. Thank you.
Yeah, definitely, Gwen. We might not have this hour now. Thanks a lot. It was an awesome discussion round. So I'm really happy you are self-sustaining your discussion. So maybe we can leave, Jose, what do you think? We can leave them here, but maybe we don't, otherwise we don't finish all the agenda. So it's maybe time to go to Jack from FEIBO. So we can give you the floor. Is that everything set there?
Yeah, it seems to be okay. Thank you.
Very good. Then ready to roll.
Okay. I had the connection problem earlier, so if the screen freeze, you can just terminate my session anytime.
Okay. No, hopefully not.
All right. Oh, sorry. Go to the first slide.
Yeah, you have still to share the screen. So first the green button. And then,
yeah, is it working?
You have to still share the screen. So the
yeah,
green button
did.
on the
so
bottom.
That's just a problem with the connection.
Okay.
Yeah. Is still.
No, but let me check, because I might have your slides myself.
Okay.
Let me check. Oh, I have it long ago. In our chat, yes, let me check.
Yes.
So maybe I can share for you.
Okay. So before I start, I just want to apologize. So I got the meeting mixed up with another different topic. So what I prepared is not entirely semiconductor processing related. Actually, it's related to PCB processing. But we did do some work on the semiconductor. So I will probably cover some of the work we did during my presentation.
So now let's see if I'm as bad. Okay. Can you see the presentation, the right screen?
Yes. Yeah.
Very
Please
good.
Go to the next slide. Yeah. So please go. Yes. So we are. I'm the founder of FEIBO Laser. FEIBO is founded in 2012. And so currently we have about 200 employees. We have 2 factories in China. In total, we have 7,300 square meters clean room space. So since we founded, we have delivered over 6,000 medium to high power fiber lasers to the both industrial and scientific markets. Please go to the next slide. Next slide, please. Yeah, so regarding to the PC, yeah, okay. So those are the products we're currently having. So as you can see, we have a nanosecond pulse fiber lasers all the way to 200 watts, and we have a multi-kilowatt CW fiber laser from 500 watts all the way to 30 kilowatts. And we also have a low power tunable pulse fiber laser. And the last one is a linear polarized multi-kilowatt CW fiber laser, but it can also operate at a QCW mode, which we can use to, using external optics to frequency doubling to 532 It's a product. It's on our product roadmap. We don't have carry a green, laser yet, but by the end of the year, hopefully we can introduce a 500 watt green laser, CW and QCW operated into the market. So next slide, please. As to the PCB, so we this is PCB mainly for LED lighting. Using the LED lighting for the car or for household lighting or office lighting, and people are using aluminum substrate or copper substrate, just for heat dissipation. So as you can see, it's a multi-layer structure. You have aluminum substrate and epoxy, and on top of it you have copper foil, and you have corrosion inhibitor and different materials. So previously they use. Can you go to the? So this market right now there are roughly about 1,000 aluminum-based PCB manufacturers in Guangdong province alone. We estimated that in total there are 4,000 manufacturers just for manufacturing aluminum-based PCBs, and so we estimate it could be up to 2,000 laser cutting machines required for this market, and 150 to 200 million euros market. Next slide, please. So here, I want to show two videos, but because of the the slow network connection, so I'm not going to show the video. Basically, we are just do a side-to-side comparison between the CNC milling machine and the laser precision cutting machine, and basically, the CNC milling machine, of course, is very cost effective. It's very cheap. It's somewhere between 20 to 30 K euros per unit, as compared to the laser processing machine is 70 K to 100 K, depending on the configuration. Whether you have an automated loader and unloader, or you have some post-process quality check module. Could you go to the next slide, please? Yeah, so for this work, what we did is we are offering a CW, QCW dual mode kilowatt fiber laser. Is single mode and can have a rep rate up to 1 megahertz modulated. And what we call it is a preset cut M2 and H1. This is different power level. Can you go to the next slide, please? So we just to show comparing to the CNC, what we can offer is what we call the total ownership cost. So we just do a case study, do a financial analysis, and what you can see here is we do have, in terms of the processing speed, is much faster comparing to the CNC milling machine, and we have as to the cost. When you're manufacturing per part, is reduced the cost by 36%. So this is already considering the the depreciation of the capital equipment investment. Please go to the next slide. So one of the other advantage we noticed is there's on the epoxy layer, so the shrinkage due to it's still a thermal process. So comparing to the CW laser and using instead of using a CW laser, we use a QCW laser. We do notice much better finished surface quality, surface quality, as well as lower shrinkage on the epoxy. Okay, go to the next slide, please. Yeah. So next slide, please. So this come to, because we're offering the QCW fiber lasers, we do have customers in the ceramic, either aluminum oxide or aluminum nitride. the thin and also silicon wafer customers who are using our QSW fiber laser for scribing and drilling applications. Maybe I can, if there's, some of you are interested, we can discuss more offline. So let's come to my last slide. As the tradition is to ask 2 questions: what we can do for you. So definitely we can offer you our standard or customized fiber laser sources, and also we can provide you information regarding to marketing and sales channels in China. We can help you to, if you want to make connection to the laser and laser processing community in China. What you can do for us, actually we are currently looking for sales representatives in Europe, just starting to, and also we are looking for joint application work addressing business opportunities in both Europe and China. We do have an application lab. If you ever have the chance to visit Shanghai, you're welcome to drop by. And also we are looking for partners, actually suppliers in specialty fibers and deep shaping optics. That will conclude my presentation. Thank you all.
Thank you very, very much, Jack. It's great always to have you at the EPIC meetings. You have been connected with so many members. It's amazing how we are engaging FEIBO as a key company in China, but also very well known in Europe and also very well known by the whole supply chain. You are looking for specialty fibers. That made me extremely happy because this is one of my passions. I also know a company in Limoges. I know a company in Limoges that makes fantastic photonic crystal fiber. Where are my Glow Photonics people today? How are you doing today?
I'm good. And you?
You're going to give a presentation later at the end, but when the thing is warm, you cannot let it cool down. So FEIBO is looking for a specialty fiber. What kind of fibers can you help with here? Yeah, could you specify a bit better the kind of a specialty fiber Glow Photonics is going to make for you?
Oh yeah, sure. So the fiber we are looking for, there are 2 types of fibers we're looking for at the moment. One is multi-layer high energy delivery fiber. Preferably have 2 or 3 layers with power handling capability up to 40 to 50 kilowatt. That's one of the specialty fiber we're looking for. The other one actually is for photonic crystal fiber, because we are in the development work to do some ultra fast laser development. So we are looking for PCF suppliers, which can meet our requirements. So yeah, those are the 2 we are looking for at the moment.
Yeah, definitely interesting for me, to be honest, because I saw at the beginning of the meeting, I am the guy who is not exactly at the right place, but that's good, Jack, to hear that you're interested in a specialty fiber, to be honest. And yes, of course, Glow Photonics, it's a very small company, but we are making a local fiber since 10 years, something like 10, 12 years. And we're making a local fiber mainly for ultra-fast laser, like femtosecond and so on, and for high power, high energy. So if you're looking for a local fiber, PCF fiber, of course, we should add some fiber for your need for infrared, for UV, and so on. So there is some place to discuss on that, of course.
Okay, great. Yes, we should definitely connect offline.
Yeah. Sure.
Yeah, when it comes to PCF, Glow Photonics is one of our key members. So do you know Glow Photonics? You can give me 10% commission on this. I'm going to go to Coherent. Dirk has a question.
Yeah, I do. Thank you. Thank you, Jose. I have a question for Jack. So I know that the fiber market in China is pretty crowded, and it's a pretty competitive marketplace. So how do you differentiate yourself at this company against all these competitors in the Chinese fiber market?
Yes, yeah. I mean, the general fiber laser market, I mean, for general application like sheet metal cutting, it's very crowded, and it's very, customers, they are very price sensitive, and but there's another big market for material processing is welding. When the welding is still, I think for the laser processing penetration level in that particular market segment is very low, and you can. So what we are doing right now is using design different pulse shaping and energy. Basically different power distribution, both transverse and temporal, and to address a different welding application, the customer's needs. So that's one thing we're working on. The other one is focusing on the precision, like for example, this composite materials cutting. You have to use you cannot just use a simple sheet metal cutting laser for that application. So we also work very closely with end users to address their specific needs. So that's what we are focusing on right now. The other one we are doing is on the medical laser side, because medical laser market is right now is relatively small. It's very diversified, but if you hit the application that really can make can take off, the market can take off very quickly. Because China has 1/4 of the population in the world. I mean, yeah, the medical market is huge here, huge potential.
Indeed, and we organized a meeting on medical laser a few days ago, and it was already quite a boom on the kind of connections that we made afterwards. I love when EPIC members get to know each other, and I also love when a company in Barcelona, which is one of the most beautiful cities in the world, introduce themselves. Igor, you are representing Monochrome today, or key company in laser diodes. What are you doing at a Laser for Semicon meeting?
Yes, thanks for the introduction, Jose. I'm representing Monochrome. We are in general focusing on diode lasers, and we also produce solid state lasers. And we are trying to approach more industrial fields. And so I just was wondering, what are the needs in the semiconductor manufacturing industry to understand these kind of market better and maybe find some collaboration?
Thanks very much, Igor. I think there's no better area than this square that you have in front of you for that kind of connection and communication. We are going to go now to Munich. From China to Munich, we go to TOPTICA, and we also would like to give you the floor. Today, this week, I saw from TOPTICA, they had the new brand, TOPTICA Eagle Yard, in beautiful blue. I really like the new branding on that, Holger. It looked fantastic. Congratulations. The floor and the attention of everyone goes to you.
Thank you, Jose. Welcome, everyone, and thank you for having me join here. I'll speak a bit about what TOPTICA is doing in areas in direction of semicon. Let's see. I hope you can see my screen well. Thanks, Jose. All right, so just a brief introduction to TOPTICA. We are a company founded about a little more than 20 years ago, and we have a broad range of products. We have subsidiaries around the world, including now it's not Eagle Yard Photonics anymore, it's just TOPTICA Eagle Yard, a provider of the high power laser diodes, also a broad wavelength range. We have like a mid-sized company, I would say. So we are small enough to make customized solutions, even to an individual scientist, but also large enough to provide serious volume production for the industrial grade for OEM solutions. And that relating to the semicon part, I'm focusing a little bit on two very briefly, because I mean, for us, not being in the high power regime, for us, semicon is both manufacturing but also quality control. Actually, several of our products focus on quality control applications, and having the full range of femtosecond pulse, picosecond laser sources, as well as frequency stabilized laser sources. We are driving all of these applications in some way. I will only speak about a few key things here. One, also fairly briefly, is just to mention it here in this community, we are providing seed lasers, femtosecond and picosecond seed lasers. to drive multi-watt applications. Our customers are then building multi-watt laser systems to do this. We have thousands in the field, so this is one example where we provide industrial-grade systems on larger volumes. I don't want to go into detail here because this is maybe not the most exciting product we have for today. One I would like to speak a little bit longer about is, and that also relates to Hans-Ulrich Zuehlke speaking about pulse on demand. This is our pulse on demand laser. We have developed a femtosecond laser with true pulse on demand, permitting us to do varying scanning for advanced scanning solutions, where you keep the pulse energy constant, and this permits you to go into patterns, as you see on the left side. When you have and write a pattern, then of course, if you have a fixed repetition rate, the distances between your spots vary because your scan speed changes. But with adjusting the repetition rate with the advanced pulse control of the femtofiber vario, you can keep the same distances. And of course, you can also change the distance if this is what your application brings. It's a variety of target applications. This actually was developed for ophthalmology, for surgery, but we see a potential here also in the industrial micromachining world. It's a microjoule laser. So for the lower power end, this could be a direct system to do micromachining, or it could be a specialized seeding laser if you go into further amplification system afterwards. And I'll be happy to speak about this much longer and offline afterwards, since we only have 6 minutes. Permit me to move on. Another product I would love to show here. It is our Hololito 405 nanometer system. And of course, that is an replacement of krypton ion lasers. This is what's been developed for. At the moment, one of the key applications we see is writing holographic ratings. So this is why I want to mention this here, but we also do see potential in the semicon area where the krypton ion lasers are used. It's a 1 watt stable system, and of course, key is here to lower the cost of ownership. It doesn't need water cooling, all of these advantages you have if you replace gas lasers. Then last but not least, one example going the direction of quality control. If you're not in processing, but if you want to check your processing, or if you need to prepare your systems you use for your processing, obviously, we actually get rid of this here. So this is a standard interferometric setup just for visualization. Here we have a variety of different lasers depending what the specific requirements are. This several wavelengths potential. One key part certainly is replacing helium neon lasers going for 633 nanometer, but tunable, but high coherence. You see some examples where you measure the wavefronts on a lens or on a wafer. It could also be cost optimized, small single wavelengths, single frequency lasers. Again, these will be things to be discussed offline in more detail. What will be the requirements? In a summary, we could speak for hours about the different lasers we provide in all kinds of systems. So what can I do for you? What can you do for me? I think one of the things is, as I said before, if you're looking for specific requirements, being an individual high-end system for a scientific use case, be it some dedicated OEM, or even small series for a dedicated application, we would be a partner. We'd be welcome to discuss all the crazy things. We've done a lot. At the same time, I'm more interested to learn about this field here and we're always looking for suppliers, and I hope we find great opportunities together, as Jose always says. That will be it. Thank you very much for the attention.
Thank you very much, Holger, for your talk. So I would say it's clear that you already said someone you want to talk to, so you have the perfect laser for Hans-Ulrich. But also Ben wants it as well. Let's see what he has to say.
Yes, actually a question. I mean, you mentioned it's not the most interesting thing of your talk, but for me it was the quality control. And you was using Raman spectroscopy, right? And to highlight the stress, I guess, on a wafer level. We lately, I think 1 or 2 months ago, published an article where we used micro Raman to detect the sidewall after the separation process. And we had a very good correlation between the tensile stress level that we can measure using micro Raman and overall then the quality in terms of breaking strengths. And I mean, we did it just on a basic study, but it was very interesting and very good outcome. Maybe I can forward you our paper, but have you also think in that direction? Because in terms of process control, that would be amazing to have here a little bit more details.
I'm glad you mentioned this, and I'm definitely interested to receive your paper. We are looking in a broad variety of applications there. Since we are really a pure laser provider, not a solutions provider, for us it's interesting to understand in more detail the end application from you, and then partner up and team one with a company who would actually then build a solution system that would go into an Infineon factory. And we have some first indications here and there about things like this, but it would be definitely interesting to move this forward with maybe more speed.
All right. Thank you.
Very good. Then we will definitely find someone who can help you integrate in the system. So we make it the three connection. There's, in case, just let us know. We are here for this. So do we have other questions? If it's not the case, we might keep going, because why not? Maybe Martynas can take the floor, and so we go on with the agenda. Martynas, light conversion? Yeah, he's nodding. Please unmute yourself. Yes, if you go presentation mode.
Okay, I hope everybody can hear me.
Yes, if you can go to presentation mode, is the best to see the slides.
Okay.
Yes.
So, hello, everybody, and I have to admit I'm really making this presentation from very unorthodox place to do the presentation, so I'm hiding behind our corporate picture. So to talk about light conversion, we are from the same famous city of Vilnius as the first presenter. It's quite famous, at least in photonics industry, because the whole supply chain usually is there. So we are a privately owned company, again, of decent size, similar to TOPTICA, a little bit smaller than TOPTICA, and we are, let's say, scheduled to increase our manufacturing capabilities and expand the company within the coming 2 years. So what we do is basically femtosecond, let's say the femtoseconds by themselves defined all our products. So all our products are femtosecond lasers, femtosecond OPAs or wavelength tunable devices, spectroscopy systems for scientists, and different, let's say, variations. So in that sense, I would also resonate together with Holger. So we're, let's say, we can do very customized systems for scientists, but we also are doing, let's say, industrial systems that are being worked 24/7 in the production floor for tens of years. Just maybe what is the difference between our companies? We don't compete at all yet, because the power levels and the pulse energies are totally on the different magnitudes. So we are high power, high energy, short femtosecond, and TOPTICA is maybe on the lower power scale. So this is more or less, let's say, our history. I will not go through this. Maybe what is worthwhile noting, at least for this meeting, is that we do have our, let's say, 24/7 industrial experience starting from 2008. So this is when our first femtosecond lasers were installed in factories, and many companies, many large laser manufacturers did not have a amplified femtosecond system at that time. So to the best of my knowledge, these are the first installations in the production lines, and that was actually connected to semicon industry partially. So so that's kind of resonates with this meeting. So let's say, what if I need to say two things about what our company is good at? So one thing is this, let's say, long-term stability of our products, so we can really do reliable systems. Starting from 2009 to 2017-18, so our lasers do really keep on working 3 shifts without much other problems. So that's, let's say, the industrial part of our company. Also, we can do quite a lot of customizations because our pedigree is in the scientific community, in manufacturing of OPAs, wavelength tunable devices, custom systems. So whenever it comes to different customizations of a laser systems, be it synchronization up to a femtoseconds or let's say different bursting with picosecond, femtosecond bursting, nanosecond bursting, and so on. These are the systems that we also can do. And in that sense, let's say our threshold for customizations is quite low. We like to do those things, and we have a dedicated people who are doing that. Now to really to go to the topic of this meeting, I've tried listing some of the applications, let's say, that we see and we deliver. So if I need to really to say, only one thing where our lasers are going is basically a micro fabrication of different materials, usually very brittle materials, usually very heat sensitive materials. So for semiconductors, that's if it's crystalline structure, it's typically brittle. If it's a very thin semiconductor, then again, let's say that's usually where femtosecond lasers come in. And if I need to summarize, so basically, let's say it's a good example of cutting cutting of material, semiconductor material at constant speed, at constant, let's say, pulse-to-pulse overlap, and you can see how the pulse duration more or less influences. Yeah, so you can have a nice cut at picosecond or so, but still get some delamination of the layers, and at femtosecond, let's say, you can go really nicely through. With the same parameters, and that kind of tells you, let's say, okay, people are saying that femtoseconds are how to say, does not apply any heat to the material, but as let's say Nexcam was pointing out, if the overlap is sufficiently high between the pulses, anyways, you are going into thermal regime. So the shorter pulse durations you get, the less, let's say, thermal regimes you are having. And that's, again, there are very specific applications where that really makes sense. So behind dicing of LED chips, electronical chips, or silicon chips, let's say. So LEDs, I think, were with the first ones to start applications with ultra-short pulse lasers, let's say, and this is where we also were delivering with a sapphire or silicon, let's say, background. Through glass vias, this is maybe something that is upcoming. So again, you can really drill very nice holes and high quality holes for insulator levels for 3D chip stacking. Cutting of silicon carbide was already mentioned. So again, we have quite nice examples, let's say, of our lasers being used for that with very high quality, let's say, breaking strength after the cutting. Different small applications like Tycho ring removal, lift-off processes, opening of chips. Again, something really maybe strange, but again, there's also quite a large market in let's say inspection tools. And again, it's very often that electron microscopes are being used for that, but let's say opening with electrons is quite time consuming, and people do use lasers for that. And again, femtoseconds bring a little bit higher quality, so that is in some applications interesting to use. Wafer edge cleaning, mask repairs, again, that's a very high precision applications where, again, the smaller the feature sizes, the more precise you need to go. And I have this nice picture. Okay, it's not from a semiconductor, but it kind of shows you what can be done. And this is only a laser-based process where you can really, this is a glass needle, yeah, where you can make a 5 micrometer hole without damaging this surface on a 20 micrometer, let's say, diameter glass. Yeah, so it's really wavy like a hair. And with that, I thank you for your attention. And if you have a femtosecond to talk about femtosecond lasers, we're here for you.
I really love the slogan, do you have a femtosecond? And also, I also like the mug that I'm about to receive, that you actually put hot water and changes the color. So it's really, truly fantastic. So when it comes to light conversion, you have one fantastic slide about the needs from the users. I already have Benjamin raising the hand. Ben.
Yeah, very interesting talk. Thank you very much. I was wondering, you mentioned a certain application called Tycho ring removal, and you said it's just a minor application, but it's actually not that minor if you consider that almost every wafer that comes through the process flow. What are you offering there exactly? I'm very interested. And additional, I'm also much interested in the way you can cut silicon carbide. So can you talk a little bit more about this?
Again, I've mentioned Tycho ring removal as a minor application because to the very best of my knowledge, and you might correct that, let's say, it's not still done with the femtosecond lasers, or at least it's being only tested, let's say, to do that. Yeah, it is potentially a very large application, but so far ultra short pulse lasers are not being used for that, to the best of my understanding. Then let's say to address your question on silicon carbide. So yes, we do have together with our partners, let's say, developed enough. But so again, we are a laser source supplier, right? So we have some means to do some preliminary testing, and this is typically what we do with our customers. We do some proof of principle testing, but then again, we're never going to do the full process development. We're never going to build any machine or something like that. So we are a laser source manufacturer. We are interested in different things, like requests from the customers. What can be done differently? Let's say, again, I did not mention, but let's say applied conversion, where we are good at going to different wavelengths, especially the UV and very deep UV up to the fifth harmonic and things like that. So we're typically looking for different applications. We're typically have some place to test those things. And in some cases, like for through glass via, I showed you, this is something we developed. Like silicon carbide, this is something that is developed together with our partner company, let's say. So we can provide a little bit more than just a laser source. We can provide a laser source and a certain let's say cutting head for silicon carbide cutting. Again, it's only how to say a beam delivery optics with a patented way of doing these cuts. Yeah.
No, I completely understand, because that's why we're here, right? I can talk to you, you to me, and then maybe we can go to integrate it together. But the Tycho ring, it's very interesting. Okay. Do you have any application note, or maybe I will contact you then directly?
We can talk afterwards.
Fantastic. Dirk also has a question from Coherent.
Yeah, I do have a question. So you also mentioned an application, wafer edge cleaning, I think you called it. What is that about?
So it's basically again, we are not doing this application or barely only touching. So I don't know exactly the specifics, but this is where the wafer gets cutted, and then you really need to remove the edges, all the material that was added, and this is where let's say a laser can be used. So. And in some cases, let's say, depending on the materials which are coated on the wafer, then femtosecond laser is of choice.
Okay.
All right. So for me, this slide was extremely interesting. Here you told us about the different applications in the semicon industry, and you already have Benjamin very interested about the Tycho ring removal. I'm gonna ask our friend Brian. Brian, did you see this slide, and is there any process in particular that resonated with you after seeing this?
Yeah, I think this is a little bit out of the realm of the company I'm in now, but I see a lot of familiar topics up here from when I was with Electroscientific some years ago, doing micromachining. But we are using femtosecond lasers in a different technology. I've made some notes and may be in contact later when I get any particulars down on what we might be looking for. The femtosecond lasers here may be a little more powerful than we're needing for the application I'm talking about, though.
I'm going to ask you a similar question that I asked Benjamin before. If you could give me the Santa Claus Christmas list of a femtosecond laser that you are looking for, because I have great femtosecond lasers from Class 5, from Valo, from Light Conversion, from Ekspla. I could be talking for TOPTICA. Sorry, Holger, he's like saying. So if you could give me the Santa Claus Christmas list, the ideal femtosecond laser. Say $5 per unit.
Yeah, that's a good place to start right there. The reliability honestly jumped out to me. This was, very surprising to see. I wasn't familiar with this Pharos laser, so that's great. Another speaker mentioned earlier the, I forget the name of it. I'm looking for the pulse on demand. This was quite interesting as well. So I think control of the rep rate and repeatability, reliability in the semiconductor industry is really a key with laser technologies, of course.
Yeah. One of the things for the femtosecond laser industry is to have an accurate pulse shaping of the pulse in time. Is that something that has been a request from your side, or is that something that you, as soon as it's femtosecond regime, you're fine with?
Yeah, in the past when we were doing micromachining, the temporal pulse shaping, yeah, absolutely a great feature to have. Not clear in our current application if that's somewhere to go, but it's a possibility. Yeah, it's a good question.
Excellent. A couple of people that I want the end users to meet. We have Hamamatsu and Aerodiode represented, and I want them to say hello. I'm going to go to Hamamatsu first. Jim, how are you doing today?
I am well, thank you.
What do you think of the meeting so far? What connections am I going to make for Hamamatsu after this?
So we're kind of in an odd position that we obviously Silicon Dice, we work with femtosecond lasers, but we also manufacture photonic components. So some of the things that I was personally within the European market, we don't have a massive amount of business. Most of our work is in the Far East. But in terms of myself, it was more an understanding of what's happening in Europe and what people are doing in Europe. So it's been really interesting from my point of view and from a learning process, because it's not something I come across every day. My background is in laser, but slightly different. In terms of products and where I'm looking, I'm thinking a lot of this is about beam shaping and looking at how you can control the beam. So one of the products that we do is an LCOS SLM, or a spatial light modulator. Which can be used to change the beam shape, to adjust the beam, so you can change dynamically, you can change focus, you can change the mode of the beam, all sorts of things with an SLM. And I know that one of the things that our factory are looking at is whether high power UV would be interesting, which again has been raised in this some of the questions that have been asked. So it's been a really interesting meeting from my point of view, not specifically about, I guess, selling directly or buying directly, but just my learning has been.
On the topics of the SLM, one thing that I have been discussing with you and with Kiowa also in France is about how to actually program the right beam shape. I always had the same question. These guys are talking about very high fluence. Very, very high fluence, and they need sometimes very quick switch of the beam shape. Is that a challenge for you? Do you have a solution for this?
Yeah, both of which are good questions, and both of which you're absolutely right. So yes, beam. So energy density is important. The higher the energy density, the easier it is to get damage. You get beyond a certain point, then you will get damage of an SLM. In terms of creating the right beam, so if you use a top hat beam and you fill the whole of an SLM, then obviously you're giving yourself the most possible amount of energy that you can use. In terms of image and changing image, yes, that is a question, and one that I think does need some resolution. So at the moment you're fixed to about 60 hertz or something relatively slow, especially in this type of process. So that's something that would have to be addressed for it to be, I think, more used and more uptake in it in terms of industrial process. Absolutely correct, yes.
Fantastic. I'm going to go to, oh no, we have a question from Amplitude. Yes.
Yeah, from Hamamatsu. I was wondering if you see any breakthrough regarding SLM in UV, or is it something still out of the scope?
So that's a very interesting question, and one that I can't answer right now, but the answer is keep tuned, stay tuned. We are working on something. So we are continually bringing out new products. One of them, I believe, will be a new UV SLM.
We're all tuned to Hamamatsu, Jim. Thanks a lot. I'm going to go to France. I'm going to go to Sebastian. I'm going to go to Aerodiode, a new company. How are you doing today? And what did you learn so far about this meeting? What kind of connections are we going to make for you after this?
Yes, thank you, Jose. Thank you very much. I learned a lot of things, and there is a lot of potential, of course, connection. I'm already connected with a few people here. And I want to say that Aerodiode is a laser diode solution maker. We can provide solutions at nearly every stage of the industrial chain here in the semiconductor industry. We do offer a solution which enter in femtosecond lasers. For example, we do offer also some test and measurement solution which can enter in some system makers. And we also offer solution also for semiconductor industry, semiconductor makers, for mostly for the synchronization. So anytime there is a need for some low noise problem, for some short nanosecond pulse solution with laser diodes, or for some pulse synchronization or high pulse repetition rate, like hundreds of megahertz, we can offer solutions. Yes.
Thank you very much, Sebastian. I am quite amazed with the laser diode solutions that you have in the website. It's one of the best informative websites that we have. It's great, and I hope that we get a lot more value for you as a new member of EPIC. And I'm gonna go now to beautiful Vilnius, Lithuania. I'm gonna go to one of my most desired companies in the EPIC community, Ekspla. Ekspla, you know, you had Gediminas like raising the hand. Gediminas told me about Ekspla. The first day I met him, I went to see the lab, and they told him, what are this laser made from? I said, I'm going to introduce you to Kerstutis. And then we actually made so much business for them. Thank you, Ekspla, for being today with us. The floor and the attention of everyone goes to Aldas Jarousis, the head of OEM laser program. The floor is yours. Juronis. I think we have you muted, or at least I hope so.
Can you hear me now?
Loud and clear. The floor is yours.
Okay, thanks a lot. I'm just mixing up with my setup. Okay, so hi everyone. My name is Aldas, and as you already understood, I am from Lithuania, from Vilnius, and as you see, I'm already the fourth presenter from Vilnius, from Lithuania. Not from Vilnius, but from Lithuania. And so in Lithuania, we have a really big and nice community of the photonic companies. We're actually in such a small country of less than 3 million population. We have more than 40 companies working in photonics industry. So we have almost everything what's related to the short and ultra short pulse photonics in our country. So, and now, Okay.
Now you're back. Yeah.
Yeah. I'm sorry. I'm sorry for a mess. Okay. So it's our company is already 20 years has experience in development and manufacturing of short and ultra short pulse laser sources. We have close to 130 employees, and 40% of my colleagues are graduated PhDs. Okay, we have 3 subsidiaries in the UK, US, and China, as well as more than 20 representatives in other countries. So we present in almost every continent, maybe except of Antarctica. So we provide through our subsidiary offices and representative offices, we provide not just sales support, but also warranty and post-warranty support to our customers worldwide. High customer support standards let us stand out from other top-tier laser manufacturers. So we have 2 main product groups, lasers for science and lasers for industry or original equipment manufacturing. 2 out of 3 top 100 universities are using our lasers for their research. Meanwhile, number of well-known companies, starting from watchmaking, display manufacturing, consumer electronics industries, as well going to laser integrators of various spectroscopic systems, are using a broad range of our industrial lasers. So in our portfolio of industrial lasers, we have a femtolux series lasers with tunable pulse duration from a couple of hundreds of femtoseconds to a couple of picoseconds. Our Atlantic series picosecond lasers can operate at both at short picoseconds as well as at 100 of picoseconds, having pulse energies as high as close to 1 millijoule. Our robust and stable NL200 and NL230 series Q-switch lasers operates with pulse durations below 10 nanoseconds and can have pulse energies as high as 190 millijoules. While our Lightwire series ultra-fast fiber lasers are typically being used as seeding sources by other laser manufacturers. All our industrial lasers are designed to work in 24/7 regime, has a perfect beam quality parameters, and have a very versatile integration and control capabilities with other laser equipment. Our lasers are already being used for efficient dicing of sapphire wafers, silicon scribing, engraving of LED chips, PCB processing, laser liftoff of polyamide thin films, as well as laser-assisted selective electroless copper deposition on almost any dielectrics, be it different polymers, glass, or ceramics. Not to mention number of applications with brittle materials such as glass cutting, drilling, and etc. So some of those applications you saw on Gediminas presentation as well. So why we are here? So actually, we are looking and we are keen to engage into new partnership for development of semiconductor processing. So anyone who is looking for a decent laser source, we are open for such a collaboration. We are eager to use our experience in ultra-short pulse laser development in order to create customized laser sources that could address specific tasks of semiconductor processing. So thanks for your attention, and I would be happy to answer your questions.
Thank you very much, Aldas, for your talk and for your presentation of the possibility. So you clearly stated, yeah, you would like to basically address this field better, and so that's why you presented this. But from the results, so from what you heard already so far, because you were kind of late speaker, what did you learn already? So what is the starting point you can maybe work with the semiconductor community?
So actually, as I mentioned, we're already working in semiconductor field with some our partners, but we would be eager to engage even deep in that. So I marked to myself some issue that Hans-Ulrich has mentioned. And I believe that most probably we would be able to address his issue with our solutions. Because, as I mentioned, our different laser systems, they are very versatile in terms of synchronization and control capability. And we're constantly developing these capabilities of our lasers. So I believe that we would be able to help him with this issue with synchronization of the laser with beam shaping equipment.
Okay, very good. So that was already on your shopping list, let's say.
Sure, of course.
Are there other questions from the audience or from others about collaborating with Aldas, helping him? So, because if it's not the case, it's maybe the time of the fibers, the one that I almost forgot in our slide at the beginning. But of course, there is still Glow Photonics and it's here. So you introduced yourself already before, but now it's time to explain a bit more. Maybe what can you do for this market? Okay. Thank you. There you go.
Okay, perfect. So just to start, I would like to thank you, Epic, Jose, and you, Francesca, for this type of meeting. Very incredible. Yes, we are Glow Photonics. We are a small company based in Limoges. We have a very strange history, in fact, We have been first founded in Bath in 2009 in the UK. We were first a spin-off of this university. We were from the group of Feta Benabid, which is one of the founders of the technology. And when we moved to Limoges, we moved as well to Limoges. We follow this group. And so we restart the birth of the company in 2011 in Limoges. So if you don't know where is Limoges in France, don't worry at all. I think even French people don't know exactly where is Limoges in France, but we are a small country, a small city in France, but we have a great technology. We have 12 employees in Glow Photonics. 10 people making only optical fiber with a drawing tower, and 2 other people like myself making some sales, communication, and so on. So 12 crazy guys making optical fiber in the center of France. What Glow Photonics stands for, it means gas laser optic photonics, because with this specific element I will describe just after this first introduction, you can use the gas, you can use a laser and optic inside the same component, small component of about 100 of micron. We are small, but a lot of people is following us. As you can see at the end of the chronology in 2020, sorry, at the beginning of this year, 2 major players joined us at the board of the company as investors. So it's Trumpf from Germany and DMG Mori, a matching tools maker in Japan. Of course, they joined Amplitude System, which is one of the first investors in Glow Photonics. So what we are doing, optical fiber, basically we only make optical fiber. We do have a drawing tower. It means that we are able to make the fiber by our own. What is optical fiber? Basically, if you compare fiber, classic fiber, silicon fiber to optical fiber, a silicon fiber, it's a silica fiber surrounded by another silica component. The core of the silica fiber is a high reflective index, and so you can guide light through a fiber. But the problem of the classic fiber, if you increase energy and peak power of a laser and you inject into this fiber, you will damage, you will break the fiber, definitely. So one of the solutions is to guide light, to guide the laser via a specific fiber, and the optical fiber is one of the only solutions for ultrafast laser guiding. So in one of these geometry of fiber, so you can see here, and here's 2 kinds of geometry. This one is called the Kagome fiber. The other one here, it's called the one ring fiber. You can guide light like ultrafast laser, like amplitude, like conversion, and other partner can guide through this fiber. And you guide only in this core here. The structure will be here just to constrain light to stay into the hollow core. And so if you constrain light to guide into the hollow core, you can put a lot of energy, a lot of power, and you can guide ultrafast laser without disturbing the pulse. You will not increase the length of the pulse, and you will keep the laser pulse from the input to the output safe from any deformation and so on. And so we have developed different fiber in order to address different wavelengths from UV to infrared. So basically in the infrared, 1064 nanometer, 1032 nanometers, even in the green, it's 532, 515 nanometers. And we go down to UV, down to 355 nanometers, and also 266 nanometers. It's different fiber. We have different design for each fiber, but each fiber is available for this kind of wavelengths, for this type of wavelengths, a range of wavelengths. Holger fiber, it's a platform for us. We have developed a family of components based on Holger fiber. One which is, I think, very important in this meeting, it's a beam delivery family. We know that people don't want just to add an Holger fiber, they just want to plug the fiber to a system, easy system to plug and unplug the system. So we have developed what we call the patch cord for low power, low energy, ultra-fast laser with standard connector like FC connector or SMA connector. It just plugs the system. When I say you just plug the system, you need to adapt a little bit the optic before injection, but basically you will be connected to something which is very standard. And if you increase power and energy of your laser, like let's say, just to give you an example with a 50 watt, 50 microjoule ultra-fast laser at 200 femtosecond, we have developed a specific part of the family for beam delivery application. The first one is called BDS, beam delivery system, and the second one is called the BDC, beam delivery cable. Because if you increase power and energy inside this fiber, even air and gas will become something which is become non-linear and could destroy, damage the fiber. So we need to evacuate the fiber from gas, and so these two components are sealed to specific cells in order to evacuate the core of the fiber from any gas and any dust and so on. So with this type of components, the BDS and the BDC, you will be able to guide ultra-fast laser from point A to a point B, and you can move the fiber, and the laser beam will remain safe at the end of the fiber. Based on the Holger fiber, we also developed another brand of products which is called FastLas and ComBlas. I mentioned just previously that you can evacuate the core of the fiber from gas, and you can also fill the Holger core with gas. And if you do that, you have two different families. The first one is the FastLas. We fill the Holger fiber with gas, and we play with specific gas, with specific pressure, and we're able to compress the pulse of femtosecond laser. So basically, if you start at 200 femtosecond, we're able to go down to 30 femtosecond at the end of the system, with which keeping a lot of energy at of the input beam, something like 80% transmission efficiency through the system. And what we can do also with the Holger fiber, we can transform a laser from a single frequency laser to a multiple frequency laser by Raman conversion. So if you start at 1064 nanometer, we can move a little bit the wavelengths, and we can also go down to the UV by Raman conversion with a specific system. So you can cover different applications with this laser. We can change the wavelengths, we can change the pulse, and also we can guide the laser, ultra-fast laser, from a point A to a point B in a machine in an optical path via this Holger fiber technology. So it's a short introduction to the technology, and I hope it will give you some idea to work with you. Thank you.
Thank you very much. Merci beaucoup, Jean. I think it's been such a great meeting, and I think we have so many potential collaborations. Are there any questions for the most beautiful photonic crystal fiber I have ever seen in the market? Actually, I went to Limoges to visit the tower, and actually we organized a meeting there on a specialty fiber, and I really realized how amazing it is Europe, in the sense that companies, even small companies, can afford their own manufacturing towers, and they actually can pull fiber to the demands of the laser industry. Is the laser industry demanding enough fiber for keeping the tower fully in capacity?
That's a good question. In fact, that's a good question, Jose, because we are, let's say, a mature technology right now, to be honest, but we are still trying to push people in the laser industry to use these components, because it's a game changer in my point of view. When you're not still using free optics, you change the free optics for just a cable, let's say, but there is some change in terms of meaning to address this market. So yes, we have a lot of contact with different partners in the laser industry, a lot, to be honest. But yes, for us, we need to address different markets. We need to address different components like frequency conversion, fast laser, also the pulse compression, in order to keep the fiber drawing capability, in order to keep the fiber running every day and to be able to live every day.
Holger, I'm going to ask you the same question I asked the users today. If you could have the ideal laser for fiber lasers, the Santa Claus Christmas list of specialty fiber, what kind of thing would you ask Glow Photonics?
I think, of course, being also in the short pulse business, but not in the high power, I would be interested in having a delivery fiber with zero dispersion and no limits on how much power I can put in there. And obviously there will be some limitations, but I was still impressed to learn about this more, and I'm looking forward to actually have more discussions on this.
I think it's been a really great meeting. I'm going to go to Benjamin because, of course, he was the star of the show today. I'm going to call it the Benjamin meeting. Benjamin, if you could give a couple of final remarks because we have the next coffee of the day, what would be the main learning points you got today?
Oh, the main learning points. I mean, I had so many interesting information that it's not clear yet which is the most interesting one. But I mean, a lot of upcoming new hot technologies are knocking on the door, and I'm happy that I be informed via EPIC. So a lot of potential, but I cannot mention now one clear favor. I think Lars with NextScan is very interesting, and also what Gwen doing I think is nice, and of course coherent and light conversion are some very interesting laser suppliers.
Lars is always the grote ding, the biggest star of every meeting. So I'm really happy that he joined, and he always makes sure that everybody on the user side and on the potential partners and customer side, they always find a potential collaboration. So thank you, Lars, again for a great contribution today. For me, there were five learning points I got. The first one is, it looks to me on the semicon side that all the challenges are related to the fact that you have so many different materials in the layer stack. The layer stacks are getting more and more complicated. And now you have laser processes that actually target a layer but don't affect the other ones. And that's it comes with oxide, metals, passivation, and now the sapphire is coming and the germanium is coming, and germanium is a scattered material, so we go to another one. So this is for me the biggest challenge. But when I translate to a photonics challenge, and especially the presentation from 3D Micromac was very interesting there, they were talking about femtosecond synchronization, beam shaping, and pulse shaping, and even pulse peaking. And I think that's one of the learning points. There is a lot of opportunities here for the femtosecond synchronization. When it comes to the beam shaping, of course, we all want the ideal top hat. I don't know whatever is possible, but of course, it looks to me that we are now looking to scan very big surfaces, and laser scan technologies had something very interesting there, but there is a lot of opportunities to collaborate with them in order to deliver this very stable top hat over the whole length of the surface. And a very interesting wavelength tunability. I'm always quite amazed on the potential of wavelength tunability of many other ultrafast laser manufacturers. But today I saw the interest on the user side, and that actually rang a bell to me. I think there is a lot of opportunities there. I put here one, courtesy of Joel, one slide on the different process steps that we are targeting on the semicon, and I also put here on the ultrafast side the presentation for light conversion. I show once again, great presentation. It was really good how they actually told us the kind of unique points that are targeted with the ultrafast laser business. Thank you very much also FEIBO and all the partners for sharing their unique selling points and their demands. Now, of course, the ball is in your court. Francesca and I are going to relax, make all the introductions, but relax. The ball is in your court. It is time for you to do business. It is time for you to be epic. It is time for you to continue enjoying the online technology meetings. Let's keep active. Let's continue growing. And on the 15th of July, Francesca will sing de Nessus dorma, vincero. Until the next time. See you. Bye-bye.
Of course, don't miss it. Bye-bye.